This is video number 7 for Computer Science 2124. And this really is like a soap opera. Think of it this way. The videos form a linked list. They're all connected to each other. No, that's not a good metaphor. Scratch that. When we finished last time, we were talking about Operation 8, which I believe was moved to back. Better have been. And we had even, in thin air, already figured out an easy way to do that. We already had a move operation called move until it returns false. And I suggested that's a bad idea because that could take a long time for a long list. And I rather ominously said if we want to improve on that, optimize that so that it's order 1, then there's going to be a price to pay. In fact, there is. I'll make this a discussion. And start with the question I have. Well, it wasn't a question. How can this possibly, but I'm not going to waste the ink by writing possibly, how can this be order 1? Question mark, exclamation point. Take the same amount of time on a list of length 2 as it does on a list of length 2 million. Here's the price we have to pay. Maintain. That's to maintain a new state variable, private variable. I need to choose one of those terms. I'm sorry. A new state variable. It's in the private section, but it's a state variable that always points to the last node in the list or points at the last node. And we'll even give it a name. Points at the tail of the list. Tail. Maintain a new state variable. They're adding up. We already have the head. We already have the cursor. Now we have the tail. I don't know about you, my stress level is rising a little bit. Why? Because every time you add a new state variable, that means you've got to go back and possibly rethink every single operation you've done up to that point. You've got to ask yourself this question. Does this operation affect or use this new state variable in any way? And often you'll find out that it's yes. Every time you've got a new state variable, you've got to go back and rethink all of the things you've already figured out. But let's see. Let's just keep going. I'm not going to worry you to death. I am going to go ahead and have a class invariant for that. Class invar, double quote, make it look official. The tail always points to the last node on the list. Tail, always, well, underline everything. Tail always points at the last node in the list. Quick review, class invariant. Any member function whatsoever after the constructor has done its stuff, any member function gets to assume that this state variable tail points at the last node in the list. They don't have to check and see. They don't have to test and see if tail arrow next to 0. I know tail arrow next to 0. Why? Because the last node in the list has a 0 pointer. The tail has to point at the last node in the list, put 2 and 2 together, and there you have it. So the class invariants, even though we have to keep our eye on them, they actually drastically simplify our lives as linked list member function designers. But again, the member functions have a responsibility to this. They've got to contribute to the effort. If they temporarily, for whatever reason, point the tail somewhere else, or maybe they end up having the tail point somewhere else, then they've got to make this true before they leave, before they hit their own closing curly bracket, or before they return true or false or whatever. Tail always points to the last node in the list. You know what? I told you this could affect other member functions. This goes clear back even to the constructor. Revised constructor. The constructor is the serious workhorse when it comes to these class invariants and state variables and everything. The before picture has gotten complicated, even more complicated. I'll abbreviate. Head, H for head, C for cursor, T for tail. Before, those are all garbage. After, they are not allowed to be garbage. All class invariants must be set in place. So head, cursor, and tail. Head came first. Head has to point to that empty head node. Empty head node will have a 0 pointer because it's the last node in the list. Cursor has to point at some node in the list. There's only one thing for it to point at. Tail always points at the last node in the list. Well, guess what? The last node in the list is also the first node in the list. It's the only node in the list. So what we end up with is all three of our state variables, head, cursor, and tail, all three initially, by the end of the constructor, will be pointing at the empty head node, but all for different reasons. Head, got to be the front. Tail, it's got to be the end. Cursor, I just got to point somewhere. I can't be 0. So it did change that. Now, I didn't really fully answer the question, did I? Another slice aboard. 8. The before and after picture, just visualize this. I think I did the before and after picture last time in the discussion of why we don't want to use the move operation in this. Move to back. How could we possibly now make that an order 1 operation? Well, set cursor to tail. And just like that, voila, we made that as easy as the move to front operation. If all the member functions are going to play by the rules and make sure the tail always points at the last node in the list, then this is all we got to do to move to the back of the list. Now, if we use our linked list to implement a queue, bouncing back and forth between the front and the back, those are trivial. One statement each. Go to the back of the list, set cursor to tail. Go to the front of the list, set cursor to head. Done and done. It's just that now we've shouldered off some of this responsibility to some of the other member functions, and we are really going to have to keep an eye on those. What do I mean by that? Well, we go back and even think about what few operations we've implemented. Well, 8, that's not few. We think about whether or not any of those could possibly need to affect the value of the tail pointer. The move doesn't. Move is not going to change the tail pointer. Move to front has nothing to do with the tail pointer. What else we got? Constructor, we already looked at that. You know what? You know what? We are going to have to revise the insert operation. Think about that while I'm erasing the board. I warned you. New state variable, another mouth to feed. Got to go back and rethink all the stuff we already sunk. Revise insert. Where might this make a difference? And by this make a difference, I mean the tail pointer affect the way that the insert operation has to work. Here's a case. Here's the head. We've got 3 of them now. Head, cursor, tail. Head, da-da-da-da-da, cursor, points at this node. JKL, P. I haven't used no P yet. Tail. In most cases, the tail's just hanging out there at the end, waiting for somebody to put something the last node in the list. Oh, what if the cursor and the tail are equal to each other? In which case, we are inserting a new last node in the list. Here's what's going to happen. Our perfectly good insert, when it was unaware that there was a tail pointer, because there wasn't one yet, it said, you know what, I can do that. That's not a special case. I'm going to make a temp node. Maybe after P comes, well, I was going to say double P. Let's not do that. Let's do R. After that, node R. The pirate node. And our insert operation as it is already should be able to handle that. And we're not even going to move the cursor because we don't have to, and we're not going to do things we don't have to do. But our class invariant, if this is butchering the before picture, trying to turn it into our desired after picture, we can't leave it like that. Why not? because the tail is not pointing at the last node in the list anymore. We just now appended a new last node in the list. Go back and rethink. How much rethinking do we have to do? Well, all we got to do is put a line at the end of our insert function, tail equals tail arrow next. Oh heavens, no! If tail had already been pointing at this, then we don't want to move tail off the end of the list. In the general case, we will not adjust the tail pointer. It's this boundary condition, this one special case where the cursor was already pointed at the last node in the list. Now we got to figure out a couple of things. We got to figure out how to detect this special case. Then we got to figure out what are we going to do about it to detect. And I don't have the numbers of the steps memorized. I apologize for that. But we can go ahead and do the insert. The insert's going to happen. Let's say that we've gotten it up to this far. Temp is still there. Temp is a local variable. It hasn't disappeared yet. We can use it if we need it. To detect, how can we detect that? Believe it or not, there's actually more than one way. If tail arrow next to 0. No, that's a class invariant. Tail points at the last node in the list. We better not use that to check it. What about cursor? Look at this. Cursor equals tail. In other words, cursor was already pointing at the last node in the list. I'm not going to explore all the possibilities because I found one that's good enough, necessary and sufficient to check that cursor was pointing at the last node in the list. If cursor equals tail, ta-da! If cursor equals tail, then our special case is kicked in. That means that we just now, with the insert operation we already had, we just now inserted a new node in the list. So what can we do? You know what? Poor temp, it doesn't get a lot of mileage. We could set, think about this, temp is still down here. I just didn't even, poor little temp, I didn't even let it point at node R, but it still is. But another way, I'll use the variables that are on the board and keep ignoring temp. You're just a temporary. We could set tail equal to tail arrow next. If cursor equals tail, then we must have just now inserted a new last node in the list. Set tail, not cursor. I almost said cursor to cursor arrow next. Oh no, that would really mess stuff up. Set tail to tail arrow next. Is that a big deal? No, but it is a deal. You can't ignore stuff like this. If you add a new state variable, a new mouth to feed, you got to go back and rethink your operations. You got to go back and revise the ones that could possibly need or use or set a new value for our state variables. This is our dog intermission. Actually, I'm going to take a longer intermission than that. Next up is the remove function. I've got several pages of notes on just the remove function. It's almost like a grand finale in a way because it has all kinds of special cases we got to check. It involves all of our head, cursor, tail variables. You name it, it's got it. So I'm going to procrastinate. You could appreciate that, surely, and say, I'll see you online.